So welcome to the first page of our review packet. This is actually page 2. Page 1 is the cover sheet. So what is going to happen here is you are going to get credit for watching the Edpuzzle video, including the questions that are embedded in that Edpuzzle. So make sure you pay attention. And then you'll also turn in your written work. If you have any questions on this, please ask us for some help. That's what we're here for. So let's get started. I'm going to do blue. So this first section is going over what is a function. Most of what we do in algebra is function. There's a couple of rules. The first one, okay, so I guess I don't have a pen, is you can't have any x values repeat. So we can say, I'm working with a new stylus, not stylist, stylus. So it needs to be, anyways. If the x is unique, then it's a function. If it's not unique, then it's not a function. You would use this when you're looking at points or numbers. Now, if you're looking at a graph, you would look at the vertical line test. So let me just explain. And remember, this is all review. If you have a point, let's say I have the point, 3, 2, and 3, 5. This is not a function. And the reason why is that these x values are not unique, not function. So I'm just going to kind of plot these. So let's say that's the 0.32, and then we have the 0.35. If I draw a vertical line, let's see if it lets me move this. Nope, doesn't let me move it. It's not a smartboard. Anywhere. Here's a vertical line. It crosses these 2 points at the same time. So that means it's not a function. Okay, so in this section, determine if the following tables represent functions. To be a function again, unique x values. So we're only looking at the x's. We're not looking at the y's. We don't care about those right now. You're only looking at the x's. So you have option 1, option 2, option 3, and option 4. Off to the side, you are going to answer the question, which of these functions are, let me rephrase that. Which of these tables are functions? So here, when you look at the x values for number 1, they're all unique. So this one is a function. For option 2, the 2's repeat, not a function. Option 3, these are all unique, so it is a function. And option 4, the 6's repeat, so not a function. So options 1 and options 3 are functions. Now here, determine if the following mappings represent a function. I'm going to pause this for a sec and just write these mappings down in coordinate point form. So in this first mapping, your first column is x, and our first oval. Your second column or oval is y. And the arrows connect points. So my first point is 2, -1, then 4, -1, and then 6, 0. All of these x values are unique. So this one is in fact a function. Now, for the second one, let's see, this guy right here, over on the question, type in your reasoning. Why is this not a function? When I write down the points, I have the point 1, 3, but there's also an arrow going off 1, 7. So that automatically means the x's repeat, so it's not a function. And then this last section down here, because we're given a graph, we have to do the vertical line test. So that means anywhere on this graph, each graph, if you draw a vertical line, if it crosses the graph more than one time at any given moment, it is not a function. This one only crosses once, no matter where on this parabola you move that vertical line. So this is a function. In the circle, it crosses one time here, so right there it passes the vertical line test. But then if I draw a vertical line here, it crosses twice, so it fails. Not a function. So for graph 3, it's an absolute value. It is a function. This fourth one looks like a cubic. It's weird looking, but anywhere I put a vertical line, it only crosses that graph at one point. So this one is a function. And then this last one, not a function, fails.